In this problem, we're given a function f of x, and we're supposed to find some information. In particular, here in part A, I'm asked to decide where the function is increasing and decreasing, and then also find any local minimum and maximum values. Actually, if I do the first part, if I find where it's increasing or decreasing, that will help me find local minimum and maximum values, because a local minimum, that would occur if the function changes from decreasing to increasing. So the function's going down and then going up at that where it changes, that's going to be a local minimum. A local maximum would be where it increases and then changes to decreases. And of course then, to find where a function is increasing or decreasing, to do that I need to look at the derivative f prime of x. If f prime of x is positive, the function is increasing. If f prime of x is negative, the function is decreasing. So I'm going to have to find f prime of x, and in this case, since it's a polynomial, I'm just going to use the power rule. So I'm just going to get 4x to the third minus 64x. That would be the derivative. I'm going to have to decide where this has critical numbers, so that's where the derivative is either equal to 0 or undefined. This is a polynomial, the derivative even is a polynomial, so it's never going to be undefined, but I can find where it's equal to 0, and what's going to help me do that is to factor it. So I've got a greatest common factor here. I can take out a 4 and I can take out an x. So if I take out a 4 and an x, I'm left with x squared minus 16. And of course that's the difference of two squares, so that'll factor as just x plus 4 and x minus 4. Now, to find the critical numbers, I want to know where this derivative is equal to 0. So if I set the whole thing equal to 0, I will get this product equal to 0. And then I need to remember that if I'm multiplying three things together and I get 0, that can only happen if one of the things is equal to 0 itself. So I set each factor equal to 0 and solve the resulting equations. Pretty easy to do here. I just get x is 0, x is negative 4, or x is positive 4. Now, I need to decide where this overall derivative is positive and where it's negative. These are where the derivative is equal to 0. So if I go around these numbers, that's where it's going to be positive or negative. And so I can sort of think about this on a number line. I'm going to have 0 in the middle, negative 4 over here to the left, positive 4 over here to the right. And this then divides the number line into 4 intervals. All the way to the left, I would have from negative infinity to negative 4. Then I have from negative 4 to 0. Then I have from 0 to 4. And then I have from 4 to infinity. And I'm going to have to decide whether each of those factors appear in my original derivative. I need to look at each of these factors and decide where each factor is positive and where each factor is negative. They can only change signs where it's equal to 0 at those three numbers. So the way I can analyze this, I typically do it in what I call a sign chart. So to do that sign chart, I'm going to look at each interval. For each interval, I'm going to take what I call a test number, and then I'm going to look at these factors, 4x, x plus 4, x minus 4, and then I'm going to multiply them all together to get the overall derivative. 4x times x plus 4 times x minus 4. And I'm going to look at a big table with that information. And I'm going to have to do each of my intervals down along the left-hand side. So we're going to have negative infinity to negative 4, negative 4 to 0, 0 to 4, and 4, come on there, and 4 to infinity. So I'm just going to take a test number in each interval. So negative infinity to negative 4, One of the numbers in there would be negative 5. Between negative 4 and 0, maybe I pick negative 2. Between 0 and 4, maybe positive 2. Between 4 and infinity, maybe positive 5. You don't have to pick those numbers. You can pick any number that would be in the interval. And now I'm just going to look at each of these factors, 4x, x plus 4, and x minus 4, right? Each of those factors, and I'm just going to decide whether each factor is positive or negative in this interval. So I just put in the test number. 4 times negative 5 would be negative. That's all I really care about. I don't care that it's negative 20. If I plug negative 5 in for x, negative 5 plus 4 is negative. Negative 5 minus 4 is negative. So if I multiply the 3 together, I'm going to get negative times negative times negative, which of course is negative. Since that's negative, that's the derivative, right? That's equal to this, which is my derivative f prime of x. And so if my derivative is negative, that actually means then that the function is decreasing there. Now I look at the next row. I put in negative 2. 4 times negative 2 is negative. Negative 2 plus 4 would be positive 2. And negative 2 minus 4 would be negative 6. So I get negative times negative. That's going to be positive. If my derivative is positive, then my function is increasing. Now I plug in 2. 4 times 2, 2 plus 4, 2 minus 4. So negative will be decreasing. And then when I plug in 5, I get positive times positive times positive, right? I'm just looking, 4 times 5 is positive 20. 5 plus 4 is positive 9. 5 minus 4 is positive 1. Positive times positive times positive is positive, so that will be where my function is increasing. So I'm supposed to find where the function is increasing and decreasing. So it's going to be increasing from negative 4 to 0 and from 0 to 4, right? I just looked for where it's increasing from negative 4 to 0, and it's increasing here from 4 to infinity. It's decreasing then in those other intervals. So from negative infinity to negative 4, and from 0 to 4. And that's the first part of this. Find where it's increasing or decreasing. What we need to do then, we're supposed to find any local minimum or maximum values. So for local minimum or local maximum, remember then for local minimum, I need to, let me make that a little nicer. Let's get rid of that. Let's see if I can write that a little neater. It's sort of hard over here on this side. Local minimum. So a minimum is when a function changes from decreasing to increasing, right? I'm going down and then back up. So where does this change from decreasing to increasing? Well, if I look over here, it's decreasing from negative infinity to negative 4. It's increasing from negative 4 to 0. So that means it must have a local minimum at x equals negative 4. Then here, so it went from decreasing to increasing. Now it changes from increasing to decreasing at 0. Well, if it's changing from increasing to decreasing, that's going to be a local max. So that's going to occur at x equals 0. And then at decreasing to increasing, that was my local minimum at negative 4. Increasing to decreasing, that's my local maximum at 0. And then it goes from decreasing to increasing again. So I'm going to have another local minimum at x equals positive 4. Now, the problem itself up here, says find any local minimum and maximum value of f of x. These are not values. These are the x coordinates where the minimum and maximum values occur. So to find the value, I have to evaluate the function at those numbers. But be careful. The minimum maximum values are function values, not derivative values. So I don't want to go here. What I need to do is I need to go back and look at the original function to find these values. So I'm going to take f of negative 4. So I'm going to plug that into the function, my original function up here in blue, right? So when I do that, I get negative 4 to the 4th minus 32 times negative 4 squared, and then plus 2. I'll leave it to you to evaluate that. If we do, we get negative 254. Then I look maybe at f of positive 4. So 4 to the 4th minus 32 times 4 squared plus 2. This is an even function, so the fact I changed from negative to positive doesn't change anything here. I still get negative 254 then for my function value. And then my final one I need to do is f of 0. That's where I have a local max. If I plug in 0, I get 0 to the 4th power minus 32 times 0 squared plus 2, and that just gives me 2. So if I am going to report what I've got here, I had local minimum at x equals negative 4 and x equals 4. So that were these values. So my local minimum values are both negative 254. So my local min is negative 254. Now that actually occurs twice, but I don't really care about that. It will affect the graph, we'll see later. The local max then, my maximum was at x equals 0, so this 2 is my local maximum. So that's part A. I found where it's increasing and decreasing. I found the local minimum and maximum values. Now, if I go to the next page here, we're supposed to find where the function is concave up or concave down. So to do that, concavity is based on the second derivative. I need to know where the second derivative is positive and where the second derivative is negative. So from what I've done before, we had our f of x given, we've calculated f prime of x. Now I need to find the second derivative, f double prime of x. So f double prime of x, I'm just going to take the derivative of my first derivative. So I come here and I take the derivative of this. So 4x cubed, I bring the 3 down, I get 12x squared minus 64, right? The derivative of 64x is just 64. Again, to figure out where this is concave up or concave down, I need to figure out where this second derivative is positive and where it's negative. Where it changes from positive to negative is when it's equal to 0. So I'm going to have to be able to solve this and get it equal to 0. There's a couple ways you could do that. You could factor it. That's sort of how WebAssign does it. It's almost easier in this case since there's no x term or anything like that. I could just use the square root property. If I set it equal to 0, I'm going to get 12x squared equals 0. 12x squared minus 64, equals 0, which is going to say 12x squared equals 64. So x squared is 64 over 12. I can divide top and bottom by 4. That gives me 16/3. So then to get x itself, I'll take the square root. But if I decide to take the square root, I have to do plus or minus. So I get x equals plus or minus 4 over the square root of 3. Now, a lot of the time you learn to rationalize that. That doesn't really matter for what we're doing here very much. Again, that's where my second derivative is equal to 0. So if I go around those places, that's where it's going to be positive or negative. So if I make a number line for this, we're going to have negative 4 over the square root of 3 over here. And we're going to have positive 4 over the square root of 3 over here somewhere. You might want to figure out, we're going to need test numbers on either side, so we sort of need to know about what decimal this is. If you do that on a calculator, we get that that's about negative 2.31 and positive 2.31 if we do those as decimals. So if I look at intervals around here then, keep doing that. My first interval then would be from negative infinity to negative 4 over the square root of 3. Then I'm going to have from negative 4 over the square root of 3 to positive 4 over the square root of 3. And then from positive 4 over the square root of 3 to infinity. Those would be my intervals that I'd get around those places where the second derivative is equal to 0. So now I make a sign chart. So I'm going to have my interval. I'm going to need a test number for each interval. And then I'm going to need I'm going to need to figure out where this derivative and look at whether it's positive or negative. So 12x squared minus 64. I'm going to have to just evaluate that. I'm not going to have to look at the factors here because it's a relatively simple derivative. So negative infinity to negative 4 over the square root of 3 is my first interval. Now that's really about negative 2.31, so I just need something over to the left of that. It could be negative 3, right? And if I put negative 3 in here, negative 3 squared is 9. 9 times 12 is 108. 108 minus 64 is definitely positive. Now that's my second derivative, right? That's my second derivative here. That tells me whether it's concave up or concave down. So if my second derivative is positive, that means it's concave up. My next interval then, negative 4 over the square root of 3 to positive 4 over the square root of 3. Something in between there is 0. And if I plug a 0, 12 times 0 squared is 0. 0 minus 64 is negative 64. So I get a negative second derivative. That tells me this is concave down. And then finally, my last interval from 4 square root of 3 to infinity. Again, 4 over the square root of 3 on the calculator, we see that's about 2.3. So if I go over there, it would be positive 3 would be a test number in that interval. 3 squared, 9 times 12, 108, minus 64, it's still a positive like it was for negative 3. So we get, again, it's concave up. Okay, so I'm supposed to decide where this is concave up and where it's concave down. So it's concave up from negative infinity to negative 4 over the square root of 3, and from positive 4 over the square root of 3 to infinity. And it's concave down on that other interval from negative 4 over the square root of 3 to positive 4 over the square root, this isn't liking me, square root of 3. Okay, so those are the intervals where it's concave up and concave down. And then I'm supposed to find point of inflection for this. So the coordinates of any point of inflection, let's see, did I have another page for this? Yeah, I left some more space for that. So we figured out where it's concave up and concave down. Now I need to find any points of inflection. And so to do that, I need to evaluate the y-coordinate. Remember, to get the y-coordinate, I have to go back to the original function. Okay, so I'm going to have to go back to this original function. To find points of inflection are where a graph changes from concave up to concave down. So in this case, it's concave up from negative infinity to negative 4 over square root of 3. But then at negative 4 over the square root of 3, it changes to concave down. So at negative 4 over the square root of 3, it stops being concave up and it starts being concave down. So we have a possible point of inflection at x. Well, we do have a point of inflection at x equals negative 4 over the square root of 3. So it was concave up, then it's concave down until positive 4 over the square root of 3. But then 4 square root of 3 to infinity, it goes back to concave up. So there's another point of inflection there. So at x equals 4 over the square root of 3. Now to find my y-coordinate, I need to evaluate f at these values, plus or minus 4 over the square root of 3. Now in general, I would have to calculate those separately. But when I look at my original function f of x here, f of x, all my exponents are even. So whether I put in positive 4 over the square root of 3 or negative 4 over the square root of 3, for this particular function, it's not going to make a difference. That would be different if I was plugging it into the derivative, which I wouldn't do, but those have odd powers, so then the plus or minus would give me something different. But since I'm plugging into the original function, I really don't have to worry about plus or minus here. What I'm going to get when I plug it in, we get plus or minus 4 over the square root of 3 to the 4th power minus 32 times plus or minus 4 over the square root of 3 to the 2nd power plus 2. And if you're having some trouble here with the square roots, you can think of this a couple ways. The numerators are easy, right? 4 to the 4th, 4 times 4 times 4 times 4 is 256. What I get in the bottom is square root of 3 times square root of 3 times square root of 3 times square root of 3. Over here I get 32. Oh, I left off my squared up here, didn't I? So 32 times, I get 16 over 9 plus 2. Now, when I look at this here, square root of 3 times square root of 3 is 3. Square root of 3 times square root of 3 is 3, right? 3 times 3 is 9. So this is 256 over 9 minus 32 times 16. I can do that on a calculator or something. We get 512. I have a mistake up here, right? Square root of 3 squared is not 9. It's square root of 9. This should be 16 thirds. So 512 over 3 plus 2. If I'm going to want to put these together, I'm going to need to get a common denominator. So I might want to think of this as being over 1. And if I change to denominators of 9, I get 256 over 9. Multiply top and bottom by 3. I get 1536 over 9. Multiply top and bottom by 9 here. I get 18 over 9. So when I combine this together, I get negative 1262 over 9, which is approximately negative 140.22. But if I look for the points of inflection, then my x-coordinate, I would have 2 points of inflection. The x-coordinate would either be plus or minus 4 square root of 3, and the y-coordinate would be this negative 1262 over 9. So those are my points of inflection. Now I'm supposed to sketch a graph of the function just to see how this all fits together. Of course, my y scale has to be pretty big here. What we found is this is information that we've already found then from earlier. We know where it was decreasing and increasing. We knew where we had these points. So I need to get all the way down to negative 254. So my scale is going to be a little crazy here. I don't have very many positive. My maximum there, relative maximum, is 2. So I know I've got, this point here. I'm going to have a point here, 0, 2. If I look at my other relative minimum points, those are at plus or minus 4. So if I come over here at negative 4, or I come over here at positive 4, I'm going to have some points there, but they're going to be pretty low, right? Negative 254 down here somewhere. So, negative 4, negative 254 would be like that. Positive 4, 254 would be like that. Those are my relative minimum and maximum points. I also have my points of inflection. These coordinates, we said, what did we say? 4 over the square root of 3. I did that on that other page, right? That was about 2.31. 2.31 is going to be sort of in here somewhere, negative 140. That's going to be somewhere like that. And negative 2.31, I'm going to have a point somewhere like this, right? Negative 2.31, negative 140, and then positive 2.31, negative 140. So those are going to be these points. And now I look at this from negative infinity to negative 4, it has to be decreasing. So the function has to be coming down till it hits this relative minimum. Then it's going to have to come through this point. It's going to be concave up until it hits this inflection point. Then it's going to switch to concave down, go through this maximum, come back, and loop around. So it is doing this decreasing and increasing like we've said. So in general, the graph, I don't know exactly where it crosses the x-axis. We could figure that out perhaps. So my graph is going to look something like that. And that's this problem.